Curious about the hidden science driving the next generation of digital artists? You're not alone. Every time you scroll past a surreal AI-generated landscape or a portrait that looks like it came out of a Renaissance dream, there's one powerful engine behind it: Stable Diffusion. And today we're pulling back the curtain on this game-changing technology. Welcome to the AI Artistry Lab. If this is your first time here, this is the place where creativity and code collide, where we make the complex world of AI a little more human and a lot more fun. This is the very first episode in our brand new Stable Diffusion Blueprint series, and trust me, it's going to be a wild, mind-expanding ride. In this kickoff video, we're laying the foundation for everything that follows. We're talking about what Stable Diffusion actually is, how it works under the hood, and why it's such a transformative force in the world of digital creativity. Whether you're a curious beginner or someone who's played around with AI art tools, by the end of this video, you'll have a clear and confident understanding of the basics, and we'll do it without frying your brain. Let's start at the top. Stable Diffusion is a deep learning model designed to turn words into images. Literally. You give it a prompt, like a steampunk elephant walking through Times Square at night, and it returns a high-resolution, never-before-seen image of exactly that. Magic? Not quite, but close. This model exploded onto the scene in 2022, and what made it different, what made it powerful, was that it was open source. That means anyone could download it, tweak it, and create with it. Before that, similar tools like OpenAI's DALL-E were locked away behind closed APIs. Stable Diffusion kicked the doors open and let the world in. Developers, artists, tinkerers, meme makers, everyone suddenly had access to this AI artist that could paint with language. Now, Stable Diffusion doesn't work by directly creating an image pixel by pixel. That would be computationally intense and painfully slow. Instead, it uses something called a latent diffusion model. Picture this. Imagine you start with a blurry mess of an image, and each step in the process helps it become clearer and clearer. Like a sculptor chipping away at a block of marble until a statue emerges. That's essentially what's happening, but in a highly abstract mathematical space. Here's the basic flow. First, the model encodes an image into a latent space. Think of this as a compressed version of the image, packed with meaning but stripped of unnecessary detail. Then, noise is added to this compressed version. Yes, on purpose. Why? Because training the model to remove the noise is how it learns to create. Finally, in the reverse process, the model learns how to take that noisy mess and reconstruct it back into something meaningful, guided by your prompt. That's the magic of latent diffusion. It allows the model to operate efficiently, so even folks with consumer-grade GPUs can generate incredible art from text. Let's take a peek inside this AI wizardry and look at the major components that make Stable Diffusion tick. First up, the text encoder. This is where your words go in. Ever type, "a photorealistic tiger sitting on a spaceship," and wonder how the model understands that? That's where CLIP comes in. CLIP is like a translator between human language and machine understanding. It turns your prompt into what's called an embedding, a set of numbers that capture the meaning of your words in a way the AI can work with. Then there's the UNet, which is arguably the brain of the entire operation. It's the part of the model that handles the messy job of denoising. It goes through several steps, constantly refining the image and aligning it with the meaning from the text encoder. The U-shape of its architecture isn't just for looks. It allows the model to understand both the big picture and the tiny details at the same time, which is crucial when turning randomness into structured beauty. Once the noise has been cleaned up and we've got a clean, latent representation, the decoder steps in. This piece converts that compressed, abstract version of the image back into something we can see, a full-resolution, visual masterpiece. It's often built on VAE, or Variational Autoencoder, which helps keep things efficient and relatively fast. And finally, there's the scheduler or sampler, the behind-the-scenes conductor. This part decides how much noise to add or remove at each step of the process. It's all about balance. Too fast and you lose detail, too slow, and it becomes computationally expensive. There's a whole world of innovation going on in this area, with names like Euler, DDIM, and DPM++, SDE pushing the boundaries of what's possible. Some recent breakthroughs, like MIT's DMD framework, have made sampling way faster without sacrificing quality. That means we're heading toward a future where you could generate ultra-detailed images in seconds, not minutes. The most famous use case of Stable Diffusion is obviously text-to-image generation. You write a description and boom, you get a brand new image. But it doesn't stop there. There's image-to-image generation, or IMG to IMG. You can feed in an existing image and use text to morph it into something new. Want to turn your doodle into a digital painting? Done. Want to change a photo style from comic book to oil painting? Easy. There's also inpainting, which allows you to edit parts of an image using a prompt. Say you want to remove someone from a photo or change a background. Stable Diffusion can do that with a few clicks. On the flip side, outpainting can expand an image beyond its original frame. Start with a portrait, and Stable Diffusion can generate a full scene around it that blends in naturally. And then we have ControlNets, a major recent upgrade. These give users even more power over the generation process. Want to control a figure's pose? Define edge outlines? Adjust the lighting depth? ControlNets act like steering wheels for the AI, guiding it with surgical precision. This tech recently got a huge boost with the release of ControlNets for Stable Diffusion 3.5 Large, offering support for blur, canny, and depth-based control. But we're not just talking about still images anymore. Stable Diffusion is edging into video generation with tools like Stable Video Diffusion, pushing into territory once ruled by massive animation studios. And then there's 3D asset generation, like Stability's AI Fast 3D and Tencent's Instant Mesh, where the same diffusion principles are helping generate 3D objects from simple text or image prompts. And don't think this tech is limited to art. It's seeping into areas like medical diagnostics, financial forecasting, even AI-generated code. Stable Diffusion isn't just creating pretty pictures, it's reshaping how we interact with information, systems, and the very definition of creativity. Now look, we get it. Words like latent space, UNet, and embeddings can sound like a foreign language. But part of our mission here at AI Artistry Lab is to make this world feel less intimidating. We've broken this down into chunks today for a reason. Understanding AI models like Stable Diffusion is a process. It's okay if everything didn't click immediately. This is just part 1. Each new video in this series will add another layer, another brushstroke on the canvas. The best way to learn is to get hands-on. Try it out for yourself. There are plenty of free or low-cost tools online where you can play with Stable Diffusion, no coding required. Tweak a prompt, run a few generations, see what kind of magic you can coax from the machine. So, to sum it all up, Stable Diffusion is a revolutionary text-to-image model that works by adding and removing noise in a special compressed space called latent space. It's made up of key parts like the text encoder, or clip, the denoising UNet, a decoder to generate the image, and a scheduler to coordinate it all. It's open source, widely accessible, and the engine behind the explosion of creativity you see in the world of AI art. But we're just getting started. If this video helped you understand Stable Diffusion just a little bit better, smash that like button, subscribe to AI Artistry Lab, and hit the notification bell. In part 2, we'll dive into the world of prompts, how to write them, structure them, and use advanced settings to really unlock the potential of this tool. Until then, keep experimenting, keep creating, and keep exploring the boundless space where art meets artificial intelligence. This is just the beginning. Our Stable Diffusion blueprint is being built brick by pixel. Thanks for watching. Please like the video, press the subscribe button, and also drop your thoughts in the comments section.